Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! Integer just means whole number, so we're looking for all the whole numbers that satisfy these two inequalities. Well, the first inequality says that it has to be greater than 3. So the smallest number that is greater than 3 is 4. The second inequality says it has to be less than or equal to 8. So I'm just going to keep going till I get to a number that is less than or equal to 8. It can't be 9 because 9 is not less than or equal to 8. So our answer is 4, 5, 6, 7 and 8. So we're going to first of all work out where 9 is on the y-axis. Well, we've got 8 here and 10 here, so 9 will be halfway in between. And what we're going to do now is just draw a line across at 9, and then wait until it hits the line, and then we're going to draw a line down, and you can see here that x is 1. So our answer is that x equals 1. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135, and the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225, and so our answer is 225. So the first thing we need to do is work out the mean for the data in the table. So to start off doing that, we're going to work out the midpoint of each group. So we've got 80 to 85, and to find the midpoint, you add the 80 and the 85 together, then you divide by 2. So this will be 82.5, then 87.5, then 92.5, then 97.5, and then finally 100 plus 105 divided by 2 is 102.5. Next we need to find the FT, which is just the frequency times the duration of calls. Now, in this first group, we're not timesing it by 80 to 85 or anything like that. We're timesing it by the midpoint. So our midpoint effectively becomes the T. So we're going to do 15 times that, which will be 1237.5. And we're just going to keep going and multiplying each of these together. And then finally 2050. Right, next we need to add up the frequencies and add up the FTs. So we're going to have the sum of the frequencies. So I'm just adding all this column up, and that will be 80. And we have sum of the FT, And so we're going to just add this column up here. And so that would be 7,450. So what this column represents is all the numbers added up together. This column represents how many numbers we have. So to find the mean, it's all of the numbers added together, which will be 7,450, over the amount of numbers we have, which is 80. So when you do that, we get 93.125. Now this question is about the improvement that we've made, or that the manager has made, the call centre's made. So we're looking at subtracting the 93.125 away from the last week, which was 105. So we're looking for improvement. And we're going to do 105, take away the 93.125. And that's going to be 11.875. Now it does ask for 2 decimal places, so that will be 11.88. Okay, so we're going to start by writing this out a little bit bigger, give us a bit more space. So it's minus 6x is less than 60. And we're going to do our tram lines down. And we're going to start by dividing both sides by minus 6. Because that's what this is doing, it's timesing the x by minus 6. So we're going to divide both sides by minus 6. So that gets rid of the minus 6 on the left hand side. And it's going to be 60 divided by minus 6, which will be minus 10. Now we've got to be really careful here, because whenever you times or divide both sides by a negative, you must switch the inequality. So instead of pointing to the left, it's now going to point to the right. So our answer is x is greater than minus 10. The formula y equals mx plus c includes this m, and the m means the gradient. So if we're looking for something that is parallel to y equals 9x plus 18, we're looking at this number here. And for it to be parallel, it needs to have the same gradient. So we could just write y equals 9x plus or subtract anything, or we could just write y equals 9x. I'm going to say plus 5. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got 2 sets of parallel lines here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78, and we must write down the reason. So corresponding angles, and corresponding angles are equal. Now here we've got an equation, and we want to solve it, so we get our lines in. We'll go first of all add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also 2 parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. So we know that James knows that he has a square. So we can actually get rid of all of this bit. It's not relevant at all to the question. And the question asks, what is the probability that the square is blue? Well, there are 3 blue squares, so it will be 3 over, and how many are there in total? Well, it says the total is 17. So the answer is 3 over 17. To find the largest weight this package could have been before it was rounded, let's do a quick number line. And we're going to just do it between the 24 and what it would round to next. Well, it's 10 nearest kilogram, so the next thing it would round to is 25. The cutoff point for rounding is here. And that's going to be halfway between 24 and 25, which is 24.5. And that is actually going to be our answer. Now, some of you who are astute might realise that 24.5 would round to 25, but theoretically the biggest it can be is going to be 24.49 recurring. Let's just draw that a bit better, 24.49 recurring. And that is actually the same as 24.5. In your exam, however, you can write 24.49 recurring and you would get full marks, but for brevity, I would definitely recommend writing 24.5. So to find the gradient, we need the formula or the equation in the form y equals mx plus c. And the m there will give us what the gradient is. So we're just going to be rearranging this equation. And so I'll get my lines in. So the first thing I'm going to do is get rid of the x's from the left hand side. And we can do that by adding 6x both sides. So we've got 6y equals, and I'm going to put the 6x first, just to match the y equals mx plus c. Right, the next thing I'm going to do is get rid of this 6 because we just want a y there. So we're going to divide by 6 both sides. So we've got y equals 1x plus 36. Now we shouldn't really write 1, but because we're looking for m, we're looking for the number before x, I've kind of left it in there to show that the gradient will be 1. The first thing we need to do is work out the area of the floor, and you'll notice that this is a trapezium. So with a trapezium, the formula is half a plus b times h, and a and b are the parallel sides, so these ones are the parallel sides, and the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula. So it'd be half a plus b h. So half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack. So we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, the next thing we look at is the fact that the Jenny has a 25% discount. So we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount. and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence, so I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160, take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. There's a lot going on with this question, so I'm going to start off just having a look at the total amount of money. So I'm going to do this in pence, so 2,115 pence. And if each merit point is worth 3 pence, then we can work out the amount of merit points by doing 2,115 divided by 3. So that gives us 705. So there's 705 merit points. Next, have a look at the question here, this part here, where it says James has X merit points. Sarah has 4 times as many points as James, so she's going to have 4x. Robert has 69 fewer merit points than James, so he's going to have x minus 69. And we know that that equals 705 because we've just worked that out. And this feels like a solving coming on. So we've got x plus 4x plus x, which is 6x. Minus 69 equals 705. And we're going to add 69 to both sides. So we've got 6x equals 774. Then we're going to divide 6 both sides. And so we've got x equals 129. So x equals 129. That means James has 129. Sarah has 4 times more, so she will have 516. And Robert has 69 fewer, so we're going to take 69 away from that, and that will equal 60. So in this question we are told that the centre of enlargement is at 6, 4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here, and so that would be -4, 1. So when we're asked to find the position, we're basically finding out what n is, and we're told that the sequence has a 39 in it, and we're finding the position of 39. So we're going to equal the nth term to the 39 and solve it. So we're going to put in our solving lines. And the first thing we're going to do is take away 15 from both sides because we want n on its own. So we get 6n equals 39 take away 15, which is 24. Then we're going to divide 6 both sides. And so we get n equals 4. So 39 is the 4th term in the sequence, and you could write it out. You could put n equals 1, n equals 2, n equals 3, and just keep going till you get to 39, or we can do the method we've just done, which is solving it. So to find the locus of points that are 10 centimeters away from a point, you need to measure 10 centimeters on a pair of compasses, and then you put the point at A and draw them. Now I'm going to try my best to do this. It's probably not going to look perfect, but I'll do my best. And the length here, which is supposed to be, probably isn't exactly, but this part here is going to be 10 centimeters to get the full marks, and obviously you want the circle to be a little bit nicer than the one I've drawn, but try and get it as perfect as you can. And the best way of doing that is just don't push down too much and just move the page around with your compass being stationary. So here we're asked to factorise a quadratic, and we know it's a quadratic because it's got an x squared term, an x term and a number term. And what we're going to do is we're going to be, first of all, putting two sets of brackets down with an x at the start of each. And what we're trying to find is what number goes here and what number goes here. So we're going to start by looking at this minus 45. And it's a special number because we're looking for two numbers that multiply together to make that minus 45. We're also going to look at this plus 12 here because we're looking for two numbers that add together to make that 12. So what we can do is write out the factors of minus 45. And so that's going to be minus 1 and 45, minus 3 and 15, minus 5 and 9, and then the same but the other way around. So 1 and minus 45, 3 and minus 15, and 5 and minus 9. Remember, we're looking for them to add together to make 12. So we look down the list here, which ones add together to make 12. This one here, minus 3 plus 15 is 12. So our answers will be minus 3 and plus 15, or the other way around. The formula for an exterior angle for a regular polygon is 360 divided by the amount of sides. Now here we're given the fact that the exterior angle is 30, and we're looking for n, so we just need to rearrange the equation. We can times both sides by n. And then divide both sides by 30. And so we've got n equals 360 divided by 30. And when you do 360 divided by 30, we get the answer of 12. So it's a 12-sided shape. To solve this, we've got to first of all factorise the left-hand side. And so we look at the number, and it's definitely a difference of two squareds. So x squared the square root of that will be x. And we think about what the square root of 144 is, which is 12. And so we plus 12 and we minus 12. So difference of two squares, you take the positive and the negative root. Now to solve, one of these brackets is going to equal to 0. So we're going to do the first bracket equal to 0. So we've got x plus 12 equals 0. And we're just going to put our lines down and take away 12 both sides. And we get x equals minus 12. So one of our solutions is minus 12. And we do exactly the same thing to the other bracket. So get it equal to 0 and solve. So add 12 both sides. You'll notice something about the numbers here, that they are just exactly the same. And that's because when you find a solution, you get the number here and you just change the sign. So that becomes minus 12 and that becomes plus 12. So we're going to go through this shape and work out the area of each of the shapes in the triangular base prism. So we're going to start with this triangle at the front. And the formula for working out the area of a triangle is half times the base, which is 12, times the height. And so that's going to be 54. Next thing I'm going to do is work out the rectangle here. And so the width of it's 23 and the length is 15. So we're going to do 23 times 15, which is 345. We're going to do the base of the triangle or rectangle, at the bottom. And so that is going to be 23 times 12. And that is 276. And the next thing we're going to do is this rectangle at the back, which is going to be, I'm going to call D. And that is going to be 9 times the width, which is 23. So that's 207. Now we do have another triangle, but actually that's the same as A. So when we're working out the surface area, we're going to do 2 lots of A plus B plus C plus D. And that gives us 936. So the answer is 936 centimeters squared. So I'm going to start off just with a quick sketch, and we know that the bearing of B from A is 85 degrees. So we're going to have A here and B here. And let's just draw a line between them, and let's do both our north lines. And so we know that this angle here is 85 because it's the angle on the bearing of B from A, so it's 85 degrees. So now it says work out the bearing of A from B. So the first thing we can do is actually just draw a line going down here. And we know that this angle here will also be 85 degrees. Because of alternate angles. It's always best to write that down somewhere, so we can just put in brackets here alternate angles. And we know that this angle here is going to be 180 degrees, so it's a straight line. And I'm not a fan of doing the reasons on the diagram, so maybe perhaps I should have labelled this an X and this a Y and written X equals 85 and Y equals 180 somewhere else. And so to work out what the bearing is, I just need to do 180 plus 85. So 180 plus 85 is going to be 265 degrees. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power 4 w to the power 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power 4 w to the power 5. Some people will try and do something with the v to the power 4 w to the power 5, but if you think about it, if I just draw out my square, if it's 11v to the power 4 w to the power 5 all the way around, when you add, you don't add the v to the power 4, w to the power 5. It's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power 4, w to the power 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11 v to the power 4, w to the power 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power 4s together, and remember with indices, if you times two powers of the same base, and they're both v, then we just add the powers together, so that'd be 8. And we're going to add the w to the power 5s together, so that makes 10. So it's 121 v to the power of 8, w to the power of 10. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I'm going to pick a point on my shape, and the the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. So the first thing to notice with these simultaneous equations is the coefficient of y is the same. And so what we're going to do is just copy out the equations and just make them a bit bigger. And we're really looking at the signs before the 6y's. And we'll eventually be going downwards. Now we're either going to be add or subtracting going downwards, and the point is to get rid of the y's. And these signs, if they are both the same sign, then we're going to subtract. If they are different signs, then we're going to add. So D in different is the D in add, the S in same is the S in subtract. So looking at them, they are both the same, so we're going to subtract. And we don't just subtract these ones, we subtract all of these. So we're going to look at the difference of all of these. So 6x take away 4x is 2x. 42 take away 32 is 10. Get our lines in. And we're going to divide 2 both sides. So 2x divided by 2 is obviously x, which is the whole point, and 10 divided by 2 is 5. So x equals 5 is our first solution, but we've got to find out what y is. And to do that, we're going to just substitute in the value of x into the first equation. So we've got 6 times 5 plus 6y equals 42, and then we're just going to solve that. So we get our lines in. And first thing we're going to do is take away the 6 times 5, or take away the 30 from both sides. So we've got 6y equals 12, and then we're going to divide by 6 both sides to get what y equals. So y equals 2. Now we can check that by putting the values of x and y into the second equation. So 4 times 5 plus 6 times 2, and that does equal 32. It's sometimes easier in these questions to view these triangles as 2 separate triangles rather than one triangle. So we're kind of just going to split this triangle off and just move it to the side so we can see what's going on. I'm going to do the same with the smaller triangle and kind of move that to the side. So we can see we've got 2 triangles here. We've got a big triangle and small triangle. And we can label the sides of them as 18. Now this long length would be 20 plus x, 20 centimeters plus x. Then we've got 6 here and we've got x here. Now the 2 triangles are similar because the sides here we assume are, well, we know they are parallel because they are right angles. And they share an angle here, which we can just label as A. And so they are definitely similar, which means that one is an enlargement of the other. So we need the scale factor first. Now if you look at the 6 and the 18, they are what we call corresponding sides. So we need to work out the scale factor by finding out what I multiply the 6 by to get to the 18. Well, that's obviously going to be 3. So we now know that we can times the x by 3 to get to the 20 plus x. So we can write that down. 3x, I'm timesing the x by 3, and that will give me 20 plus x. And so I can solve this now. Subtract x both sides. Always subtract the smaller amount, so 2x equals 20. And then divide both sides by 2. And so we've got x equals 10. So we know that x equals 10, it says find the length x, and so that will be 10. So we can't work out length CE directly, but what I'm going to do is I'm going to start off by finding length BC. and I'm going to do that using trigonometry. So we've got the 90 degrees there. So it will be, well, we'll start by labeling it. So BC is the hypotenuse, the opposite here and adjacent here. We're not using the adjacent, so we're going to just do our SOHCAHTOA, and we've crossed out the A, so we cross out these two, so it's going to be sine. So we know that sine 79 equals the opposite, which is 29 over the BC. So I'm going to put my solving lines in, and we need to times both sides by BC first of all. So we end up with BC sine 79 equals 29, and we're just going to divide both sides by sine 79. Just a bit of rearranging. So BC will be 29 over sine 79. And when you do that on the calculator, you get 29.542, blah, blah, blah. Okay, so next thing we need to figure out is angle BCE. So where are we? This angle here. And to work that out, we're just going to take 79 away from 90. So angle BCE is 90 take away 79, and that's going to be 11. So we know this is 11 degrees here, and we have enough information now to work out CE, because we've got this triangle here, and we've got this length here, the BC, and we've got this angle here. So we've got enough information now. So we're going to look for length CE. We're going to first of all label the sides. So we've got the opposite here, the hypotenuse opposite the right angle here, and the adjacent here. So this hypotenuse is now an adjacent. We're not using the opposite at all, but we are looking for the hypotenuse. So let's do our little triangles now, find out which one we're using. So we're not using O, so we get rid of sine and tan, and it's going to be a cos. So it's going to be cos 11 equals the adjacent, which is the BC value we've just worked out, over the hypotenuse, which is CE. Now hopefully you've realised from when we did it with the sine thing here, that actually we can just swap these two things over. So we can have it as CE equals 29.542 blah 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 over cos 11. Okay, then we put that into our calculator and we get the answer of 30.095 blah blah blah, and it wants it to one decimal place, so that will be 30.1. With these questions, it's normally easier to view these as two separate triangles. So we've got a small triangle here with 19 and 47, and what I'm going to do is I'm just going to move this out, and we've got a bigger triangle here, and we've got well, we've got a bit of we don't really know what any of the sides are just yet, but we can work them out. Okay, now we know that both of these triangles are similar, and the reason is they share an angle and the lengths at the bottom are parallel, so they will be similar, which means one's an enlargement of the other. And we are given some information in the question that the ratio of BC to DE is 1 to 6. So BC is this length here, and DE is this length here. So we're actually given the scale factor, because we know that 1 times 6 is 6. So we know the scale factor is 6, and it's asking us to find length AD. And so the corresponding length to AD, which is this one here. So all we need to do is get that 47, times it by the scale factor, so times it by 6 to get to our value. So it's 282. So we're asked to find the bearing of Freetown from Gamley. So that is this angle here. And so what we're going to do is we're going to find this angle, and this will obviously be 90 degrees because the hiker walked west, and it's against the west line and the north line, so it's definitely 90 degrees. So we can work out what the bearing is if we know that angle inside the triangle. So we're going to start by labelling the sides. Well, we've got a 90 degrees here, we've got a hypotenuse here, we've got the adjacent here next to the angle, and we've got the opposite, which is across from the marked angle. Here we're not using the hypotenuse, we can cross that out, and we can do our SOHCAHTOA. And the only one that doesn't have the hypotenuse is TOA, and so we're doing tan x equals the opposite, which is 49 over 98. Get our lines in, and we're going to do the inverse tan to both sides. So we get x equals, and we do inverse tan, which is 26.565, blah blah blah. Okay, so we know that the whole of the way around up until this point is 270 because we've got this 90 degree left. So what I'm going to do now is we're just going to work out the bearing. So bearing, we're just going to do 270, take away the 26.565, blah blah blah, and that gives us 243.434, blah blah blah. It says it wants it to the nearest whole number, so that's going to be 243. The formula for the volume of a sphere is 4/3 pi r cubed. So we're going to do 4/3 times pi times the radius cubed, which is 17. And that gives us 20,579.526, blah blah blah. So to two decimal places, that would be 20,579.53. We're going to start by drawing x equals 3.5 onto our graph. So x equals 3.5 will be a vertical line where x is always 3.5. And we're asked to find x is equal to or greater than 3.5. So where on this graph is greater than 3.5? Well, it's going to be on the right hand side of it, because all the coordinates here are more than 3.5. It's got to equal to and greater than. The equal to means that it will be a solid line rather than a dashed line. So to draw a box plot, we need 5 points. We need the lowest point, lower quartile, median, upper quartile, and highest point. Now we already have the lowest and highest points, so we can put those onto our box plot now. So the lowest point is at 0 and the highest point is at 30, as we can see on the cumulative frequency graph. So we need to now find out where the median is. Now the graph goes up to 20, the actual line goes up to 20, so the median we're going to find at 10. We're just going to draw a line across and down, and that looks like it is 17. So our median will be at 17. So we're just going to draw a line at 17. Get it just perfect. There we are. Okay, next thing we're going to look for the lower quartile. So if the median we drew a line across at 10, the lower quartile would do it at 5, which will be here. So that's at 12. So we're just going to draw a line up from 12, fill in this box, and we can actually fill it in with the lowest point. And lastly, we need our upper quartile, and we do that by adding the 5 and the 10 together to make 15. So we're going to draw a line across from 15 and down, and that's 23. So line up from 23. Try and get this as nicely as I can. I need to move that line a little bit. Oops. There we go. And let's fill in the last bit, join it up with the highest point. And there's our box plot. To find the interquartile range, we need to remember a simple formula, and that is that interquartile range is the upper quartile, take away the lower quartile. How do we find the upper quartile from a box plot? Simple, that is the bit here, which is 29. How do we find the lower quartile? It's just the bit here, which is 12. So use the formula, 29, take away 12, and that's going to equal 17. So the parts of a box plot is the lowest value is here, lower quartile, median, upper quartile, highest value. In this question, it might be easier just to draw a quick diagram. So let's draw this equilateral triangle, and it says that its lengths are all 10 centimeters. And we're looking to find the area. Now we also know with an equilateral triangle, all the angles are 60 degrees. So we can plot those, but we don't need to plot them all, we can just plot one of them. And we know that to find the area of a triangle, we can use this formula here, which is half AB sine capital C. And if we have a look at this diagram, we can label the sides. So I'll call this side, this angle C, and little c here, and little a here, and little b here. So let's put that into our formula. Little a is 10, little b is 10, and sine c, which is 60. So with A, B and C, it doesn't matter what you label A, B and C as long as the angle is opposite the side with the same letter. The angles are all capital letters, the lengths are all lowercase. Okay, so let's put that into our calculator and we get the answer of 43.301, blah blah blah. It says it wants it to 2 decimal places, so that is 43.3. To solve when we've got two equations that aren't linear, and here we've got a linear and a circle equation, what we're going to do is we're going to solve by substitution. We're going to substitute one into the other. So here we're told that y is equal to 3x plus 11, and we actually have a y in our second equation. So what we're going to do is just substitute it in. So we've got x squared plus, and instead of y, I'm going to say what the first equation is. I'm just going to replace it for what y equals in the first equation, which is 3x plus 11. And it's y squared, so it's that squared, equals 125. Okay. Now we need to expand the brackets there. And so we're going to have x squared, and you can use any method you want. And don't forget, when you square brackets, that's just going to be 3x plus 11 brackets 3x plus 11. So we're going to do 3x squared, which is 9x. So how are we going to write this? So plus 9x squared. And then we've got 3x times 11 plus 3x times 11, which is 33x plus 33x, which is 66x. And then we've got 11 times 11, which is 121. Now at this point we want everything to equal 0 because it is a quadratic. So to solve it we need it to equal 0. So we're just going to tidy it up and add the bits that need to be added, and we're also going to subtract 125 both sides to get it equal to 0. So x squared plus 9x squared is going to be 10x squared. So we might as well just write it as 10x squared. We've got 66x x on its own, and we've got 121 take away 125, which is minus 4, equal to 0. Now it says it wants our answers to 2 decimal places, so chances are these won't factorise nicely, so we're going to be using the quadratic formula. And so we need to find out what a, b and c are. So a is the number before the x squared, the coefficient of the x squared, which is 10. B is the coefficient of the x, which is 66. And c is the number on its own at the end, which is minus 4. The quadratic formula will be minus b, and I always put the values we substitute into brackets, because if they're negative, that really helps us. Plus minus square root of b squared minus 4 times a times c, all of that over 2 times a. When you put that as a plus, then into the calculator, we get x equals 0.060 blah blah blah, and when you put a minus there, we get the answer of minus 6.660 blah blah blah. Now you might think, well, how are we going to find out what the y's are? Well, if x is 0.06 blah blah blah, we've got an equation here that says to find out what y is, we times the x by 3 and we add 11. So we're going to times that first solution by 3, then add 11, and that gives us that y is 11.180 blah blah blah. We're going to do that with the next solution, and we're going to times it by 3 and add 11, and when we do that we get minus 8.980 blah blah blah. We're going to round each of these to 2 decimal places, so we've got 0.06 and 11.18, and the second set of solutions is minus 6.66 and y equals minus 8.98. To start off this question, you need to realise that EGH is a right angle triangle, and if I draw it in on the diagram, and then let's draw it as a 2-dimensional right angle triangle, then hopefully we can see how to answer it. So if we put in the values, 4 centimeters there, 5 centimeters there, and we can find length EG by using Pythagoras. So let's try and put in some Pythagoras. So we've got EG squared equals EH squared plus GH squared. And I'm just going to put tram lines down. Okay, so EH is 4, so it'd be 4 squared. And GH is 5, so it'd be 5 squared. And that's going to equal 41. And we're going to square root both sides. So we've got EG equals 6.403 blah blah blah. Okay, so that gives us what EG is. So we know that this is 6.403 blah blah blah. Now we're looking for angle GEC. So we need to draw in another triangle onto our diagram. We'll do this a different colour. So GEC, the triangle would be here. Okay, and so I'm just going to draw that triangle as a 2-dimensional triangle. And again, it's a right angle triangle. The height is 6, the width or the base of the triangle is that 6.403 blah 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 that we've got, and the angle GEC is actually this angle here, so this is angle GEC. Okay, and we can show it like that. Now to work out what GEC is, it's not going to be Pythagoras anymore, it's going to be trigonometry because we're looking for an angle. So we know that we first of all label the sides. So we've got the opposite, we've got the adjacent, and we've got the hypotenuse. We're not using the hypotenuse at all, but we are given the opposite and the adjacent. So it is going to be TOA, and those of you should know this off by heart. that the TOA shows us that the opposite will be over the adjacent. So we have tan GEC equals, and that's the angle, equals the opposite over the adjacent. And let's put our tramlines in. Okay, so let's just put in what the opposite is. The opposite is 6, and the adjacent is that 6.403, etc. And I'm keeping it in my calculator so I can make sure that I don't lose any accuracy. You can actually round it to 6.403. Just try and round it to a sensible degree of accuracy, say 3 or 4 decimal places, and that's fine. If you round it to, say, 6, then it's going to have a big influence on the answer. I'm going to inverse tan both sides to get rid of that tan, and so that would just leave angle GEC. I normally just put a little thing there to show it's an angle, and we're going to inverse tan the 6 over 6.403. Now in the calculator, what I'm going to do is type in second function tan to get the inverse tan, and then in the bracket do a fraction button, then 6 over, and then I type in answer because 403 was my last answer. It just keeps the accuracy up. It's absolutely fine. You get full marks if you write inverse tan of 6 over 6.403 and just leave it at that. That's fine. And so angle GEC is 43.138, etc. Now we don't need any more accuracy than that because it says that the answer should be to 2 decimal places. So all we need to do is round that to 2 decimal places, which will be 43.14. So we're given the graph of y equals sine x, but we're asked to find solutions for sine x equals 0.55. If we put those together, basically we need to find out what x is when y is 0.55. Because y is sine x and sine x is 0.55, so we're looking for y equals 0.55 and we're looking for what x is. So if I draw a line across from roughly where 0.55 is, we're looking for the 2 points which cross the line. And so we're looking for the x coordinates, so with these points down here. Now we can type into the calculator the inverse sine of 0.55, and it will give us 33.367 blah blah blah, but the calculator can't give us all the solutions, and the reason is that this sine graph will go on forever. So there's infinite solutions because the graph goes on forever, both on the right hand side and the left hand side. So this blue line will forever be crossing these points. So it will give us the first solution, which is good, because what we can do is, if you have a look, we've got a nice bit of symmetry down here. If I draw a line down here, you can see that the line is symmetric between 0 and 180. So if we know, which we do, what this bit here is, and we've just worked that out to be 33.367 blah blah blah, then using symmetry we must know what this bit here is, because this bit here must also be 33.367 blah blah blah. And so all we need to do to find out what this coordinate here is 180 minus the 33.367 blah blah blah. And when we do that, we get 146.632 blah blah blah. It says it wants it to 2 decimal places, so our 2 solutions are 33.37 and 146.63. So to find the shaded part of this diagram, we need to first of all work out the volume of the smaller cone, which is at the top, then work out the volume of the larger cone, which is the whole cone shown, and then take them away from each other. So the radius for the smaller cone is 4 and the height is 5. And the radius for the larger cone is 20 and the height is the 20 plus the 5, so it would be 25. So I'm just going to label them A and B. And so why don't we work out the volume for B first? And the formula for the volume of a cone is a third pi r squared h, with h being the perpendicular height. So it's a third times pi times 20 squared times 25, which is going to be 10,471.975, blah, blah, blah. We're going to work out the volume for A, and this time it will be a third times pi times the radius now is 4, and the height is 5. So that will be 83.775, blah, blah, blah. So to work out the shaded bit, we're just going to do the volume for B, take away the volume for A. So it's going to be 10,471.975, take away 83.775. And all those I'm going to keep in the calculator to keep the accuracy. And that gives us 10,388.199, blah, blah, blah. And to two decimal places, it's going to be 10,388.20. So we have the original y equals fx shown in the graph, and it says it has a minimum at 1 minus 1, so it's this one is the black line here. And we're looking to see the new function, the red function, but we notice that actually it looks very similar. It's a U shape for what we can see. It might not be a quadratic, but it looks like a quadratic. And we notice that the point at the bottom has shifted left 1, 2, 3 spaces. Now it's tempting to think that the new function will be f brackets x minus 3. That would be what would be tempting to do. But when you're looking at transforming graphs along the x-axis, it's actually the opposite of what you think. So the actual answer is f brackets x plus 3. So this one would be wrong. We're going to start off this question by finding length BD, and we do that by doing a little right angle triangle down here. And let's draw that right angle triangle out. Okay, so we've got a length of 4 on ED, length of 3 on BE, and we're looking for length BD. So we're going to use Pythagoras. So we've got BD squared equals BE squared plus ED squared. Get our little tramlines in. Okay, so BE is 3, so it's going to be 3 squared plus 4 squared, and that's going to equal 25. Square root both sides, and we've got BD is equal to square root of 25, which is just 5. Okay, we need to now work out what MD is, because we're looking for length AM. So MD is actually just going to be half of BD. So it's going to be half of 5, which is just going to be 2.5. The reason for that is that all of the lengths AB, AC, AD, AE, all of them are the same, so therefore point A will be exactly at the midpoint or above the midpoint of the square, so M is obviously at the midpoint. Okay, next we're going to draw in another right angle triangle. It doesn't actually matter which side we take. I'm just going to take this side because we've worked out what MD is. And let's draw that out down here. Okay, so we've got the length of 5 here. We know the bottom bit is 2.5, and we're looking for the length AM. So another bit of Pythagoras here. So AM squared is going to equal, and we're looking for AM, yep. AM squared is going to equal AD squared, take away MD squared. and AD squared is going to be 5 squared minus 2.5 squared, which is going to equal 18.75. Then we'll square root both sides. I haven't put my tramlines in. Let's get those in as well. Make sure it's all neat and tidy. So we've got AM is equal to 4.330, and because it says 2 decimal places, we want to write down the answer 4.33 centimetres. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.